Fine students, now we're done with problem number 6. Let's move to problem number 7. Problem number 7. In problem number 7, star, it is defined on real numbers, defined as a star b equal to a plus 2b. They are telling that show it is not going to be commutative. If you want, you can give an example. If you want, you can go it in general. If your example is to be given. Suppose if it is commutative, 2 star 3 should be equal to 3 star 2. You can create example. Maybe this will be asked for 1 mark or 2 marks. 2 marks maximum it will be. So according to the definition, this should be 2 plus 2 into 3 equal to 3 plus 2 into 3. A plus 2b applied on both sides. So the left hand side, this will be 6. 6 plus 2 will be 8. This will be 6. 6 plus 3 will be 9. Right. And clearly 8 will be not equal to 9. Therefore, star is not going to be commutative. It's as simple as that. General procedure, yes, surely you can explain. A star b will be a plus 2b and b star a will be b plus 2a. Now these two are not going to be equal. Therefore, a star b is not equal to b star. Fine. Now please call back for any topic or any problem discussion if you want to make with me. I'm always I'll be always free enough, and I can help you in any of the topic, any of the problems if you're stuck. Okay, you can call back to us, talk to us, and make sure the doubts are clear. Right. The next one, problem number 8. It is based on real numbers. Show that addition, multiplication are going to be associative, okay, whereas subtraction and division are not associative. So I will ask you to go with example. It's easy. Okay. So addition of 3 real numbers, 2, 3, minus 6. I'm going to take these 3 real numbers. So when I operate this, 2 plus 3 plus minus 6 equal to 2 plus 3 plus minus 6. Write down the elements first. Associate these two here and associate these two here. Now simplify. 2 plus 3, 5. And this will be minus 6. 2 plus 3 minus 6. 3 minus 6 will be minus 3. Clear? So what do you get here? 5 minus 6 will be minus 1. And this is going to be minus 1. So what do you notice from this one actually? We have to show addition, multiplication are associative. Clearly LHS will be equal to RHS. Therefore addition is associative. For the same 3 elements you can apply associative under multiplication. 2 multiplied by 3 multiplied by minus 6. 2 multiplied by 3 multiplied by minus 6. Associate these two. Right. So 2 multiplied by 3 6. 6. Now again this is going to be 3 multiplied by minus 6. That's going to be minus 18. 6 multiplied by minus 6 and that's going to be minus 36. 2 multiplied by minus 18. One example to just show that. Okay. Now clearly multiplication is also going to be a associative on the set of all real numbers. Let us check for subtraction. Now 2 minus 3 minus 6. Between the elements the sign should be minus. Now this will be 2 minus 3 minus 6. So let's put the brackets like this. So 2 minus 3 will be minus 1. Minus into minus will be plus 6. And on the right side 2 minus half. Minus into minus plus. So 3 plus 6. 3 plus 6 will be 9. So what happens to the left hand side? The left hand side is 5 and the right hand side is minus 7. 5 not equal to minus 7. Hence subtraction is not going to be associated. Similarly, you can go for division with the same examples, okay, or different examples. So you can clearly show it's not going to be associated. Fine. Now next, problem number 9. Problem number 9 is defined on real numbers. A star b is defined as a plus 2b. Show this is not going to be associated. So let us check the associative property. You can go with an example or you can learn the general procedure. Anything are fine. Okay, fine. Now let's consider a star b star c is equal to a star b star c. I would like to go with general procedure first. Okay. So A star B star C, by using this definition, B plus 2C equal to A plus 2B star C. So naming culture is quite good. Okay, so this will be A star X is equal to Y star C. A star X, A plus 2X is equal to Y plus 2C. Star has to be removed. Apply this definition. That's it. Now A plus 2 multiplied by X. X value is B plus 2C. And what is Y value here? A plus 2B plus 2C. Simplify on both sides. A plus 2B plus 4C. And on the right side, A plus 2B plus 2C. Certainly these two are not going to be equal. Therefore star is not going to be associated. So we have done 9 simple ones to understand the concept. So these are worked examples. You will be feeling very much easy when I started doing this worked examples, because you already worked enough number of problems, you already learned enough number of problems, so this won't be a problem at all. Okay, we can manage this quite easily. Now let's go to problem number 10. Under 10, they show that 0 is the identity element under addition, 1 is the identity element under multiplication. Okay, on what? On real numbers, but there exists no identity under subtraction and division. This will come later. Okay, so first let us discuss. 0 will be the identity element under addition, and 1 is the identity element under multiplication. So the next 3 problems are based on identity and inverse. Now on real numbers, right? For example, 2 plus 0 will be equal to 2 will be equal to 0 plus 2, identity property, right? The next, 3 plus 0 equal to 3 is equal to 0 plus 3, or minus 1 by 2 plus 0 equal to minus 1 by 2, right? That will be equal to 0 plus of minus 1 by 2. That's fine, right? Now looking into this, whenever I am adding 0 with any other real numbers, I am getting back the same real numbers here. So what is the property which is satisfied? Clearly you have to mention, after a few examples you have to mention clearly A added with 0 will be equal to A will be equal to 0 added with A. A star E is equal to A is equal to E star A. Therefore 0 is the identity under addition. Clear? In the second part is, show that 1 is the identity under multiplication on real numbers. That means first example is better. So 1 multiplied by 1, 1. 2 multiplied by 1, 2. 3 multiplied by 1, 3. Right, go with minus 3 also. Minus 3 multiplied by 1, minus 3. Minus 4 multiplied by 1, minus 4. Minus 5 by 2 multiplied by 1, still going to be. So when I multiply 1 with these real numbers, what is it I am getting back? The same real numbers. So something like A multiplied by 1 is equal to A is equal to 1 multiplied by A. It's possible to write. Therefore 1 is the identity element. Fine students, I hope the examples are making us to understand the things very much clearly, right? Okay, so take help for some examples and prove it. Now let us go to subtraction, and this part is over. Now let us go to subtraction and division, right? Suppose identity exists under subtraction. So what should be true? A, right? Minus A should be equal to A, should be equal to E minus A. This is the property under, see, the standard property was A star E is equal to A is equal to E star A. Fine. Okay. Now let me take this part. A minus A is equal to A. So minus A equal to 0, or E will be equal to 0. Right. But the problem is based on what? The problem is based on real numbers. Yeah, it exists. Let's agree. Now the second one is E minus A equal to A, or E will be equal to 2A. Fine. This is also real number. Suppose if I assume identity exists, I am getting one identity because of the first condition and one more identity because of the second condition. This shows there exists two identity element, which is not possible because identity element has to be unique. Only one identity element for the whole set. Okay. Generally, if you want an example, 1 subtracted with something should gives me 1. What is that? It should be what? It should be what? It should be. Can I just substitute some numbers and get this 1 back? This should be what? This should be 0. Fine. Now, 2 subtracted. But this is a real number problem. So there are many occasions on which 1 subtracted with some other elements can also gives me 1 only. Right. Fine. Now let's go to. But examples will make you a bit confused. I think this concept is clear now. Now let's go to division. But while defining division, they said R star, non-zero real numbers, not just real numbers here, right? So if suppose if it exists, then A divided by E should be equal to E divided by A. Can I say A by E equal to E by A? Both are same? Can never be same, right? So this can never be same. Hence identity element does not exist. Okay students, now let's go to the next problem number 11. Problem number 11, show that minus A is inverse of A under addition and 1 by A is inverse of A under multiplication on real numbers. Let us show this, right? So what does the inverse property says? But before that, under addition and multiplication I should know the identity element. So under addition, identity element will be 0. Under multiplication, identity element will be 1. Remember this. Because, let me go with the first. Right. So, under addition, identity properties are the inverse has to be written. Remember, A star B equal to E is equal to B star A. Then B will be called as inverse of A, or A will be called as inverse of B. This is the inverse property. Now, let me apply this for addition. So, A plus something. So let me call B is equal to A. This should be equal to B plus A. But remember, I already know under addition identity is 0. So what happens here, if I substitute B is equal to minus A, if I simplify this also, B is equal to minus A. So what was B? B was inverse of A. Now what is that I am getting? Minus A. So therefore, minus A is inverse of A under addition. Fine. Now similarly, if I try to find the identity element under multiplication, A multiplied by B should be equal to 1 should be equal to B multiplied by A. Remember, you cannot solve any problem of inverse without knowing identity. Even though directly they say go and check inverse, first you have to find identity and come back. If you know, it's good. If not, you find and come back. Clear? Right. Now, let's go to this now. So if I simplify this, B will gives you 1 by A. In this way also, B will still gives me 1 by A. Right. That means whenever I multiply A with 1 by A, it's possible to get back 1. Therefore, 1 by A is inverse of A. That's how it should be done. Now let's move to the last problem of this chapter or this problem, if you want to say. Right. 12th one. Show that minus A is not inverse of A under addition on natural numbers. Now this time they changed it, right? Now let us see why it's not going to be an inverse. Remember, under addition, identity value will be 0. This time the binary operation is defined as addition, correct, right? Okay. So what is inverse property? A plus B should be equal to E, should be equal to B plus A. But the only thing is, this time the problem is defined under natural numbers, but the previous problems are defined on real numbers. Suppose if I find inverse actually, now A plus B will be equal to E, right? But remember, identity value is already, but will there exist identity? First let us check that now, right? If identity exists, then A plus A should be equal to A. This shows E value will be equal to 0, but 0 does not exist in natural number. If identity does not exist, surely you cannot find out inverse, right? So if it's a problem based on inverse, first you have to find identity and come back and check, right? In the previous one it was on real numbers. 0 is a real number, but this problem is on natural number and 0 is not a natural number, right? So because of this reason, identity does not exist, hence I cannot check the inverse. So clearly minus a is not an inverse of a under addition. Suppose if it's inverse, what will happen? A minus a should give me 0, correct now? But 0 is not a natural number. Now under this there is second part. The second part is show that 1 by a is not inverse of a under multiplication on natural. Fine, okay. It's not going to be a fine, okay. Now we need to check this. So first let us check whether there exists identity under multiplication, right, on natural numbers, correct. So a multiplied by e should be equal to a, should be equal to e multiplied by a. This is possible if e equal to 1, surely identity exists. Fine, that's okay. Now let us check inverse property, right, inverse of a. If suppose inverse exists, then a multiplied by b should be equal to 1, and this should be equal to b multiplied by a. This is possible only if b is replaced by 1 by a, because when I cancel this I am going to get it as 1, and here also it's the same story, correct now, right. But this question is, a is a natural number, what about 1 by a? It's not going to be a natural number. For example, 2 is a natural number, 1 by 2 is not a natural number. Hence, I cannot say 1 by a is inverse of a under multiplication. Fine students, now we come to the conclusion of this chapter. So that is the end of the chapter. Okay, and this was the last topic where different types of binary operations will be studied. I will say I have given too many problems to sit and work out. I have given minimal problems, okay, where you can sit, work out, practice and learn the concept. Clear? So with the hope that you will just going to go through the theory, make a note of this, okay, and then you will sit and study you will sit and practice the home exercise corner, okay. So there are any doubts, any problems, any concept if you want to discuss with me, you are always welcome. Please call up and talk to any of the lecturers. Thank you. All the best.